right, good afternoon, everybody. So the topic of today's lecture is doing input and output, or reading and writing to files. And so in C, there are a couple of different ways of performing input and output. The only way we tell you how to do that in this course is through using streams. And so that's what this notebook covers. There is another way. There's a lower level way of reading and writing, or performing output, but we don't talk about that in this course. And so when we talked about Bash, I mentioned this concept of a stream. So a stream is just a sequence of data, right? And so you can sort of think of it as, you can imagine it as being an array of data. And so reading and writing to a file is sort of like reading and writing from and into an array. You can sort of think of it in that way. Another way to think about it is as a source or as a sink of characters or bytes, right? So a stream of characters would represent text-based data. A stream of bytes would represent some sort of binary data, right? And you'd have to decide exactly how to interpret the stream of ones and zeros that you're reading. Let's see. So how do you do reading and writing or input in C? So it turns out everything goes through this thing. The way that you perform reading and writing is you open up a file, and where the file corresponds to an object of big F file, or all caps file. So there's a data structure defined by the standard called all caps file, and it's an opaque type, right? So we talked about opaque types when we implemented structures and strings. Stacks and strings. And so the file data structure is the classic example of an opaque type in C. Right? And so you never work with these things directly because you don't know what's inside one of these anyway. And exactly what's inside one of these is very complicated and changes depending on what operating system and what hardware you're working with. Right? And so this is exactly what's inside one of these things is the purview of a compiler writer. So you never interact with these things directly. Instead, what you do is you make a pointer to one of these things, and you ask the standard library to either give you back a pointer to one of these things, or you pass one of these pointers to a standard library function, and it can read and write using one of these objects. Right? And so here's this quote here directly from the people who wrote the compiler. Right? File objects are allocated and managed internally by the input and output library functions. Don't try to create your own objects of type file. Right? So you're never going to make an object of type file. Right? You're always going to be working with pointers to these things. Right? So the library will do this for you. Right? And your programs only deal with the pointers to these things, and you don't care what's actually in the structure behind one of these things. Even if you knew what was there, it's very unlikely that you would be able to use it in any meaningful way. Right? You would need to know all of the gory details of how the file handling is being done by the operating system. All right, so we're always working with something that looks like that, right? A pointer to a big F file. Okay, so when you start up a C program that runs on something like a desktop computer, you get 3 streams opened for you directly. Right? So there's one called standard in, there's one called standard out, and there's one called standard error. And these correspond to the standard in, standard out, and standard error that you see in Bash. Right, so regular output goes to standard out. Regular input, so stuff from the keyboard, comes from standard in. And any error messages, by default, would go to standard error. Right? And so these streams are opened for you when you start a C program. You don't have to open them yourself. Right? So they're provided for you for free. Okay, so this part's at the beginning of the notebook, but it's really not relevant until the end. And so I/O operations, compared to your CPU, they're very slow. Right? So writing to a device that can physically store data, such as your hard disk or your flash drive or anything like that, even on a modern computer, compared to the CPU, it's very slow. Right? So we're talking orders of magnitude slower than operations on the CPU. And so typically I/O operations are buffered. Right? So a buffer is just an array. Right? It's just a chunk of memory in which you can read and write data into. So typically when you perform an I.O. operation, the reading and writing goes into an array somewhere, right? And then when the information needs to be consumed, it's read from or written to the read from or written from the array. Right? So there's 3 types of buffering in Linux. So when you open up a stream, it can be either unbuffered, fully buffered, or line buffered. Right? So unbuffered means that there is no buffer. So any I.O. operation happens, data is transferred as soon as possible when it appears. Right? So in other words, when you try to write to something like standard error, right, the content that you write does not go into an array somewhere. It tries to go directly to whatever file device standard error points at. Right? So there's no intermediate buffer. The reason this happens is because if you're printing out an error message, the user probably wants to see the error message as soon as it occurs, rather than waiting for the buffer to fill up and then the error message to be printed. Right? So in contrast, a stream can be fully buffered. And so in fully buffered, the data goes into an array somewhere. Right? When the array is full or when it's manually flushed, then the output appears, right? Or the input appears. Right? So streams that read and write to files are usually fully buffered because reading and writing to files is very slow compared to the speed of your CPU and memory. And then finally, there's line buffered. So line buffered data is transferred as entire lines. Right? So if you write out some content to a line buffered stream, that data goes into an array until a new line character appears, or the stream is manually flushed. Right? And when the new line character appears, that's when the data is transferred. Right? And so standard out and standard in are typically line buffered on a Linux machine when they're connected to a terminal. Right? So when stuff's being written to your terminal, typically it shows up as entire lines of stuff. Right? And when you are entering stuff from a terminal, right, nothing happens. Like the terminal doesn't try to interpret your input until you press enter. Right? So so there's an example of a line buffered stream. Again, this isn't really relevant until the very end of the notebook. Okay, so you want to do I/O. So you want to read and or write to a file. So how do you do it? So the idea is very simple. You create a connection to the file. So we say you open the file. Right? So that involves calling a standard library function to open the file. You then perform whatever I/O operations you need. Right? So opening the file gives you back a pointer to a big F file object. Right? You're going to perform operations using the big F file object, well, the pointer to the file object, sorry. Right? And then when you're done, you're going to close the big F file object. And so this is similar to how you deal with a dynamically allocated object. Right? You ask for memory, so that's step 1. Right? You use the object, that's step 2. And then step 3, you return the memory back to the operating system by calling free. And so that's step 3 here. Right? And the reason that you have to do this when working with files is the same reason that you have to do this when working with dynamically allocated objects. Right? So when you open a file on a Linux system, the operating system allocates what's called a file descriptor. Right? So it remembers which file has been opened. And the operating system only has a finite number of these things. Right? So once you've used up all of the file descriptors, the operating system can't do any more input or output until it gets back, until a file descriptor is returned back to the operating system. Right? So if you open up a whole bunch of files and you never close them, eventually the operating system runs out of file descriptors, and basically a Linux system will more or less stop responding because everything in Linux happens through a file. So if it runs out of file descriptors, it can't open up any new files to perform any new operations. Right. Okay, so how do you open a file? So there's one function that we care about for opening a file. It's called fopen. So fopen returns a pointer to a big F file object. Right? And how do you open the file? Well, you specify the file name. Right? So file name is if you're working with actual files on your hard disk, this would be the path name. Right? You can use an absolute path name. You can use a relative path name. It doesn't matter. Right? So that's the path name to your file. Right? And this thing here is a string that describes what do you want to do with the file. Right? And so you can read from a file, you can write to a file, or you can do both. And so the string here indicates what operations you plan on performing with the file. So if this thing succeeds, the pointer that you get back is a valid pointer, right? If it doesn't succeed, the pointer that you get back is null. Right? So null is used to indicate failure to open the file. Right? Maybe the file doesn't exist. Maybe you don't have permissions to read or write to the file, right? Or maybe some sort of error has occurred when trying to open up the file. Right? Maybe your hard disk is busted or something like that. Okay, so what are the, hang on, I'm going to scroll here first and I'll come back to the example. So the modes that you have available to you are RWA, R+, W+, and A+. And these are all strings, right? So double quoted R, double quoted W, double quoted A, and so on and so on and so forth. Right? The RW and A, hopefully they are obvious what they mean. Right? So if you open up a file with R, it means you want to read from the file. Right? If you open up a file with W, it means you want to write to the file. And if you open up a file with A, it means you want to append to the end of the file. Right? The plus operations are called the extended operations. They let you do both reading and writing, or reading and appending, or writing and appending. Sorry, can you write and append? No, A+ is append, read and append. All right, so these all do, if you try to open up a file for reading and the file already exists, right, then that's good, right? You can only read from a file that already exists. If the file doesn't exist, fopen fails, right, returns null. Now, you have to be careful with the write, because write sounds like you're going to be able to write to an existing file. That's not what happens, right? So when you write to a file and the file already exists, the contents of the existing file get deleted. So in other words, you overwrite. So in other words, the size of the file gets shrunk down to 0, and then any data that's written goes into the file. Right? So it destroys the existing contents of your file. If the file doesn't exist, you get a new file. And that's the same. That's true with append. Right? So append is the operation you want if you want to add to an existing file. But when you add to the existing file, you can only write at the end of the file. Okay, so what happens if you want to read and write to a file? Right, so that's when you're going to use R+, right? You almost always want to use R+ in this case. Right? R+ lets you read from an existing file, and it lets you write to an existing file. Right? A common mistake is to use W+. Say, well, I want to read and write from this file, so why don't I just use W+? The problem is W+ also destroys the contents of an existing file. Right? So basically, it deletes the contents of the file, and then you write into the file. You can read what you've written, right? But you can't read the previous contents, they're gone. Right? And finally, append, A+, lets you read and write from a file, but every time you write, the writes happen at the end of the file. Right? And so there's no way to write into the middle of the file, for example, if you use A+. All right, so let's look at a little example of using fopen. And so this little program here opens up that file there. Right, so that file there is just one of the notebook files that contains a text file that has some lines of text in it. Right, so I want to open up that file to read it. So I'm going to call fopen, right, with the name of the file that I want to open. I want to read it, so I'm going to use R as my mode string. Right, and that returns a pointer to a big F file. Right, whenever you're opening a file, you always want to test whether or not you successfully opened the file. Right, so if F is null, or if not F, right, that means that an error has occurred. Right? And so if an error has occurred when you're opening a file, depending on exactly what your program is, you might choose to close the program. Right? So in this particular case, all I want to do is read from this file. If I can't read from this file, there's no point in trying to continue, so we might as well close the program. Right? It might be useful to print an error message to the user. And so there's this function called perr, right? And it takes in a string. So perr will write this error message to standard error for you, but it also knows what other error has occurred. Right? So if this failed, then somewhere there's a little message corresponding to why this failed. And perr knows what that message is. right? And so if you go back, sorry, well, that's not what I wanted. Yep, I want to do this. Okay, so the p-error function is described right here. Right, so it prints a textual description of the error code currently stored in the system variable ERRNO. Right, and so in C, there is this variable called ERRNO that you can read. You can also write to it, which is very weird. Many, but not all of the standard library functions, if they encounter an error, will write to ERRNO. Right? Not all of the standard library functions will write to this variable. So it's inconsistent how this variable is used across the standard library. So if ERRNO is set to some error value, there are a set of very short strings that describe what those error values correspond to. Right? And so here's an example where someone tries to open up a non-existent file. Right? So after trying to open the file, if the pointer is null, right, they're going to use p-error to print out the error message. Right? And on a Linux operating system, the corresponding message for trying to open up a non-existent file is something like no such file or directory. It could be something else on your computer. Right? It depends on your compiler and your operating system. So that's what p-error does. It doesn't actually close your program, though. So if you want to close your program, you've got to do that yourself. Right? And so here we're going to exit with some non-zero exit code. Right? So to set the exit status of our program. Otherwise, we print out the message that we successfully opened the file. Right? And if you run that, so this file exists, it's readable to me. So if I do that, you get that message there. If you go in and you change the permissions on this file, so you make it not readable to the user, you'll get an error message down here, right, indicating that fopen failed. Notice here that I close the file. I call fclose, passing in f before the program ends. Right? So fclose is the function that you use to close a previously opened file. If you don't put this line in here, it doesn't really matter because this program just consists of a main function. When the main function finishes, when the C program finishes, any files that it opened will be closed automatically. Right, so this fclose here, strictly speaking, isn't necessary, but you should remember that you should close a file when you're done with it. Right? So that's why it's here. Right? So there's how you close a file. Right? Fclose, pass in the pointer to the file that you'd like to close, and away you go. It returns a value. No one ever looks at the return value for fclose. Right? So in principle, fclose can fail. If fclose fails, there's nothing you can do about it anyway. So no one ever looks at the return value to this function. Okay, so I told you before that reading and writing to a file is sort of like reading and writing into an array. Right? So you can think of a file as having a file position, which is just the index into an array. Right? And so the first character in the file has position 0. The next character in the file has position 1, and so on and so on and so forth. Right? Every time you read from a file, right, characters will be consumed from the file. And so if you read one character from a file, right, it'll start reading from the beginning of the file, right, and then it'll move the file position one position forward. Right? So every time you perform a read operation, the file position moves forward in the file. Similarly, when you write into the file, right, so if I write one character in the file position then moves one forward one position in the file. Okay, so how do you write or read from a file or write into a file? So you've opened up the file. We'd like to start reading information from the file now. So if you're reading in plain old text, right? So I don't have any knowledge about what's in the file. Then that's called unformatted input and output. Right. So for example, basically you're going to read in either characters or strings from the file. fgetC is a function that you can use to read a single character from a file. Right? So starting at the current file position, it looks at the character at that file position and then moves forward one position in the file. Right? If the function succeeds, it returns the character as its return value. The standard says that it returns an int, but this is for historical purposes, right? It actually returns a car. I think strictly what it says, it returns the character as an unsigned car converted to int, right? And all this is because of the very first versions of the function that, or of the very first versions of fgetC that were written returned an int instead of car. If this fails, the return value is EOF, and an error is also set. So erno is also set to some value, which you can get by calling perr. So off we go. So here we're going to read in a character from the file. We're going to read in the file one character at a time. We're going to read in the same file. Right. So open up the file. Right. Test if the opening was successful. If the opening was successful, I now need to I need a variable to store the character that we're going to read in from the file. So I'm just going to call that C. Right? And now we just want to repeatedly call fgetC until we get to the end of the file or until an error occurs. Right? So I've got this little while loop here, and the while loop looks kind of funny, I think, for most of you. So it looks like that. And the way it's written in this way because this is the correct way to write it. Right? So we're going to call fgetC. Right? Remember, fgetC returns a value, right? So it's going to return the character that was read, and we're going to store that in C. So that's what that part of the expression does right there. Right? Now in C, and in, actually, I think in all the C-like languages, so C, C++, and Java, C# probably, an assignment operation also produces a value. Right? So in other words, you can print the result of an assignment operation. Right? That's an assignment operation. So in C, the result of an assignment, the value produced by an assignment operation is the value that was assigned. Right? So whatever fgetC returns is what all of this evaluates to right there. Right? So if fgetC does not return EOF, then we know that we successfully read in a character. Right? So that's why the loop is written this way. Right? The parentheses are important here. Right, because of the precedence of this operator here. Right? The assignment has lower precedence than that. So if you don't have the brackets here, the comparison is that, right? Which is not what you want in this case. Right. Oh, sorry. That's the comparison you want, but you don't get the assignment to C, which is the problem. Right? And C gets assigned the result of the comparison, so 0 or 1. Right? We want to store the character read, so we need to do that first. Okay, so I'm going to read in C, so one character at a time. If we read in the new line character, instead of printing the new line character, I'm going to print that, so that you can actually see it's a new line character. Right? Otherwise, I'm going to write the character that was read to standard output. Right? So I don't remember if I showed you putchar, but putchar is one of the function is a function that will write the character C to standard output. Right? You could also use fprintf here if you wanted to. Sorry, printf if you wanted to. Either one's fine. If we read in something that's not a new line character, I'm just going to print the character itself. Sorry, this prints out that followed by the new line because C is the new line character. Okay, so once we've consumed the file, either we're at the end of the file or an error has occurred while reading the file. So I'm going to test whether or not the error flag has been set for the stream f. Right? So the function ferrorf tests the given stream for errors. Right? So if an error has occurred while reading from the stream f, ferror will return a true. Right? Some non-zero value. Right? So if an error has occurred on the stream, right, I'm going to print out there was some sort of I/O error. Right? If I guess the else if technically isn't necessary here, because the only way you can get out of the loop is when you hit to the end of the file if you don't encounter an error. Right? FEOF tests whether or not the stream F is at the end of the stream. Right? So in other words, in this case, have you read the entire file? Right? When I'm done, I'm going to close the file, right? And I'm going to return whatever the status was. Right? Exit success is 0, and exit failure is non-zero. Right? And so when you run this little program here, it simply consumes the file one line at a time. Right? And so you can see that the contents of that file are just the characters line space 1, followed by a new line, right? Then line space 2, followed by a new line, and then line space 3, followed by a new line. So in Linux, that new line character is guaranteed to be there, right? Assuming the file was created in Linux by a command that's completed successfully, right? So the Linux says every line of a file ends with a new line character. If you're from some other operating system like Windows, that's not necessarily the case. And so in Windows, it's possible that the last line does not end with a new line character, which can cause problems with some Linux programs. Because every Linux program expects to be able to see every line ending with a new line. Okay, so that's reading in one character at a time, right? So all you need to do is remember that, right? That lets you read in one character at a time into the character C, right? Inside the loop, do something with C. What if you want to read in more than one character at a time? So suppose I'd like to read in the entire line. That is slightly problematic, right? And so why is it slightly problematic in C? Because if you're going to read something as an entire line, you're probably going to read it in as a string. What's the problem with strings in C? They're just arrays of char, right? And what's the problem with arrays of char? You can't resize them. There's no way to resize an array. Right? And so you have to assume or compute how long is the line that I'm about to read, right? Before you try to read it into the string. Right? So fgets, right, reads from that stream, reading the characters from that stream into this string, right? And at most, it'll read in count -1 characters from the stream, right? So if you use 100 for count, fgets will read at most 100 characters into the string here until it sees a new line character. Right? If it doesn't see a new line character, it reads in 99 characters, and that's it. You don't get the new line character. Right? If your line is less than 99 characters long, that's great. str will now contain the contents of the line, including the new line character. Right? str is guaranteed to be null terminated when fgets returns. Right? It returns a string, right, or a pointer to a char. Right? And that is guaranteed to be equal to str if it succeeds. Right? If it fails, it returns null for the pointer. Okay, so how do you read in one line at a time? So it's a bit of a problem, because if you don't know how long the longest line in your file is, you don't know how long to make this string. Right? So here, I'm going to assume that every line is 99 characters or less. Right? I need an array of size 100 because I have to store the null terminator in the string. So exact same code as before, right? Open up the file, test if opening was successful, right? Now instead of using fgetC, I'm going to use fgets. So I'm going to read in the file one line at a time. Right? So here I can just call fgets and test if the return value is not null. Right? If it's not null, I know that I successfully read into the array buff. Right? So read at most 99 characters. Into that array from that stream there. Right? Fgets, you have to remember, will consume the new line character at the end of the string. Right? So if it reads in the entire line, that string has a new line character at the end, followed by the null terminator. Right? In a lot of in many cases, you don't want the new line character at the end of the string. Right? You just want to process the contents of the string. So you have to remember to remove that new line character yourself at the end. If you're just going to print the contents of the file, though, it's useful to have the new line character, because when you print out the line, you go to the next line to print out the next line. Right? And then the rest of the program is exactly the same. So when you run this thing here, you get line 1, line 2, and line 3. Right? And so there's reading there's reading a file one line at a time. Now, the way that this is written, if you have a very long line, right, so a line that's longer than 99 characters long, right, this program will still work. So it'll still read in the contents of the file, right? But inside the loop, you have to remember that this string buff is not necessarily the entire line, right? It's only the part of the line that was successfully read, right? So if you have a line that's 500 characters long, one iteration of the loop, buff is the first 99 characters, right? And then the next iteration of the loop, it's the next 99 characters, and so on and so on and so on, right? And then eventually, you'll have consumed the entire line. If you need the entire line, you can't. It's not as simple as doing this. Okay, so there's reading a character, and there's reading a string of a fixed length. Writing a character and writing a string of a fixed length is pretty easy to do. Right. So fgetC reads a character from reads one character. FputC writes one character. Right. So when you write the character, it writes into the stream at that location, goes to the next location in the stream. Right. If it succeeds, you get. If it succeeds, that is equal to the character that you wrote. If it fails, you get EOF. So now I'm going to write out. I want to write to a file. So when I open the file, I'm going to open it using W as the mode. Right? So remember, when you open a file for writing, if the file exists, it deletes the contents of the file and then writes into the empty file. Right, so here I'm going to write into the file called alphabet. It's just going to write the alphabet to the file. Right? So how do you write the alphabet to a file one character at a time? You just write a loop. Right? So our loop here starts at the character A, goes to the character Z, incrementing one letter at a time. Right? How do I write the character C? I just call fputC, right? Passing in the file to write to. Right? If there is an error, no is set, so ferror no will be able to determine that an error has occurred. If an error has occurred, you probably want to stop writing. So here I break out of the loop. Similarly, if an error occurs, if not ferror, right. So this writes out the characters ABC through Z. Right? Now remember what I told you at the beginning of the, sorry, not at the beginning, a few minutes ago. In Linux, every line in a file should end with a new line character, right? So after you write the letters of the alphabet, you should write the new line character. Right? Many Linux programs will deal with the file even if it will deal correctly with the file even if it doesn't end with a new line character, but not all, right? So it's important that you remember, write the new line character at the end of your last line, right? And then we're done. You can close the file. So if you run that program, nothing's going to happen, right? Because it writes to a file. But if you go and look at the contents of the file, where is... So I have to pull up the right one. Not that one. Okay. So this should be in the IO directory. So there's your file, alphabet.txt. Right? And so notice when we cat the contents of the file, right? We see the letters A through Z, and we also see the new line character that we wrote at the end. Right? If we forgot to write the new line character at the end, my prompt would be where the cursor is, where my mouse is right there. Right? But we're on the next line, so we know that we correctly wrote up the new line character. Okay, to write a string, instead of calling fputC, you just call fputs, right? And that will write a string to that stream, right? So it works the exact same way, right? If you want to, this one, okay. So here is this program reads its own source code, so it reads itself, and then reads itself one line at a time, sticks the line number at the beginning of the line, and then outputs the contents to another file. So here we're going to read from a file and write to a second file. Right? So we're going to open up two files in this program. So first of all, the file to read from. So that's fin. Right? Do the usual stuff. Right? Open the file. Test if we open successfully. Right? My output file is going to be fout. Right? We're going to open that one for writing. Right? So do the usual thing. Open the file. Right? Test if we successfully open the file. Right? So now we've got two open files. I'm going to read from fin and write to fout. Right? Adding the line number in front of each line before I write it. Right? So starting at line 1. Right? I'm going to read and write, remember, right? So to read from the file, I need an array of char to read the line into. Again, here I'm going to assume that all my lines are less than 100 characters long. Right? I'm just reading in this program, right? And you can see that every line in this program is less than 100 characters. Right? So there's my input string. There's the string that I'm going to read into. Right? I then want to write out some stuff. Right? So to write out some stuff, I'm going to write the contents into another string and then write the entire string into the file. Right? So string out is going to be my output string. And I want to put the line number in front of the line. Right? And so when I print out the line, well, let's look at this. So first of all, I'm going to read in a line from my file. Right? So that reads in from fin into string in. Right? Now I would like to write string in. I'd like to write the line number followed by string in into string out. Right? So I'm going to use sprintf to do that. Right? So print a formatted print into a string. Right? I'm going to write into string out. Right? How am I going to write that out? Well, I'm going to write the line number as an integer. Right? I use %03d. Right? So use at least 3 spaces in the output. Right? If I don't need all 3 spaces, use zeros to fill in the blanks. Right? So this will successfully write 999 lines, right? Followed by a space. Right? So 3 plus the space is 4, and that's why string out is 104 and not 100. Right? I need the 4 extra characters for the line number. Right? Followed by the string that I read in. Right? Here I'm relying on the fact that fgets is going to read the new line character into string in, right? Because I want to print this out line by line. Once I've printed the string to string out, right, I can then print string out to my file. So using fputs, right, write the string to the output file, right, test for any errors. Right. If I successfully write the line to the file, I'm going to increment the line number by 1. Right. And then at the end, don't forget, close the 2 files that I opened. Right. And so if you run that program there, directive writing up to 99 bytes into a region of size between 93 and 100. What's going on here? Sorry, just a second here. Writing up to 99 bytes into a region of size between 93 and 100. Yeah, that's fine, right? Am I writing to the right string? Yeah, str out is 104. Why am I getting this message? I don't understand this warning. After the lecture, I'm going to take a closer look at this warning. If you look at the output file, I believe it's that. So there's our program with the line number written in front. Right. And that's the same output that cat will produce if you ask cat, if you call cat with the -n option. Right. This is cat n. Oops, sorry. right? So that almost duplicates the behavior of cat. Okay, so there's an example where you read and write from two different files, reading from one file and writing to the other file in the same loop, right there. Okay, so that's reading and writing plain strings and plain characters. If you want to write stuff that's not plain strings or plain characters, so if you want to write numbers, for example, right, you're just going to use fprintf. So fprintf behaves exactly the same as printf, right? Whereas printf writes to a standard output, fprintf writes to the file of your choosing, right? fscanf, if you want to read formatted input from a file, right? That works exactly the same as scanf, right? So remember, scanf reads formatted input from a string, right? fscanf reads formatted input from a file. It behaves exactly the same as scanf, except instead of passing in a string to read from, you pass in the file to read from. Right? And so if you can go back to the relevant notebooks to remind yourself how those functions work. Right? So for example, if you wanted to read in a file containing numeric information, usually the easiest way to do it is to use fscanf, right? And tell it to read in whatever numbers you need to read in. Right. All right. Okay. So I guess the rest of this notebook deals with this notion of file position. As far as the assignments and the exam go, you're probably not going to be asked anything about this. But there is a nice little example of something that we can do by manipulating the file position. And so that's what this notebook now works through. Right. It turns out there's several functions that manipulate the file position information. Right? This notebook only deals with 3 of these functions. The other ones we don't cover. Right? So if you're reading or writing from a file, remember that the file position changes as you read and write. Right? So if you want to know where in the file you are, that's what the function ftell is for. Right? So ftell tells you what is the position you are currently at in the file. So it returns your position as a long int value. In Linux, it's the number of bytes from the beginning of the file. So you can interpret it, for the purposes of this course, it's the number of characters from the beginning of the file. Right. So the file that I want to deal with looks like this. Right. So it has 4 lines in it. Right. Each line has 6 characters. Right. So the first line has the letters A through E. Right. Don't forget there's a new line character after the E. Right. Similarly, there's one after the J, after the O, and after the T. Right, so in total, there's 24 characters in this file. So the valid positions for this file are 0 through 23, right? Just like the valid array indexes would be 0 through 23. Right? So I can read this thing one line. So I'm going to repeat the process of reading this file one line at a time. One character at a time. This time, every time I read a character, though, I'm also going to get the current file position. Or before I read each character, I'm going to get the current file position. So, open up the file for reading. Right. Test if we successfully opened up the file. Right. Define a character variable so I can read a character into it. Right. And now I'm going to call ftell so I can get the current file position. Right. I haven't done anything with the file yet, so POS is going to be 0 at this point. And now is my loop. Right. I'm going to read the file 1 character at a time. Right. Each time I read in the character, I'm going to print the character down here. Right. So I'm going to print the character C, and I'm going to print its position. Right. Now remember, the positions are long, so I should use %LD when I print the value. Right. And so after I read in the character, I'm then going to get the updated file position. So this is going to show you that the file position really does move 1 position forward every time you read a character. If we get a new line character, I print \n to show you that the new line character was read in. Right, so you run that. Right, and so what do we read? We read A, B, C, D, E, and then the new line character. Right, notice the position of the A is 0, position of the B is 1, and so on and so on and so forth. Right, and you can see here, by the time we read all of the file, right, the valid positions in the file are 0 through 23. All right, so every once in a while, well, not every once in a while, it is occasionally useful that after you've read something from a file, you would like to go back to the beginning of the file. Right? So one of the reasons to do this, for example, is to figure out how many lines are in a file. Right? Because you want to, suppose you want to read the contents of a file into an array, right? Where each line is stored in an array. Right? You don't know how many lines are in the file. So you have to, there's a couple of things you can try to do, right? So one is to figure out how many lines are in the file, right? Or two is to repeatedly dynamically reallocate your array that you're storing your stuff in as needed, right? So one strategy to read the contents of a file into an array is to first read how many lines are in the file, right? And then rewind the file, so go back to the beginning, right? Allocate your array that can hold however many lines that you have, right? Because you've figured out how many lines there are, right? So rewind puts you back at the beginning of the file. Right? And so I'm going to take that previous program, and instead of reading the contents once, I'm going to read it max times. Right? So to read it max times, right, I'm going to read in the file one character at a time. Right? When I get to the end of the file, I know it's position 23. Right? I'm just going to rewind the file. So reset the file count, file position back to 0. Right? Like that. Right? And then I'm going to, the count is just how many times I've read the file. So that has to be, that's going to be less than or equal to 2 in this case. Right? So if you run that program there, right, you see that it reads in the file once. Right? When it reads in the last character, it rewinds the file. Right? And then it reads in the file a second time here. Right? And then rewinds the file again and then quits. Right? All right, so you're reading from a file. You are allowed to jump around in the file. Right? So I can read a character and then jump forwards or backwards. Right? What time is it? 17. Okay, so I should, so fseek is the function that you can use to manipulate the current file position. So I'm going to stop here because I don't have enough time to actually tell you how this thing works. Right? And so we'll pick that up on Thursday. And then I think we'll look at some examples of reading and writing from files to replicate some of the command line tools that we used at the beginning of the course. Right? And then I think we'll wrap up the course probably middle of next week. Okay. Any questions? All right, that's it for today.